The universe is governed by laws of physics that seem absolute: gravity, motion, energy, and light behave predictably. Yet there exist regions where these rules collapse. These are extreme cosmic locations where matter, energy, and space-time defy understanding, revealing the true limits of our knowledge. Black holes are the most well-known examples. Inside the event horizon, gravity becomes so intense that known physics cannot describe what happens. Space-time curves infinitely, and matter is crushed into an unknown singularity, a point where conventional laws simply cease to apply. The center of a black hole is not only a gravitational mystery, it's a cosmic laboratory. General relativity predicts infinite density, but quantum mechanics forbids such infinities. This clash illustrates the breakdown of physics at extreme scales, exposing the need for a unified theory. Neutron stars also push physics to its limits. Composed almost entirely of neutrons, these stellar remnants are so dense that a teaspoon of their matter would weigh billions of tons on Earth. Gravity and nuclear forces interact in ways scientists can only approximate, challenging our understanding of matter. At the edges of black holes, strange phenomena occur. Time slows dramatically for observers approaching the event horizon. A second for someone near the black hole may be years elsewhere. These time distortions showcase that even fundamental concepts like time are relative under extreme conditions. Quantum foam, the fabric of space at the smallest scales, is another realm where physics breaks down. Fluctuations create temporary particles and energy bursts, suggesting that space itself is not smooth. At these scales, gravity and quantum mechanics clash in unpredictable ways. Inside singularities, the density becomes infinite, and the curvature of spacetime diverges. Known forces cannot describe interactions at this level. Matter, energy, and time lose meaning, and the very fabric of reality seems to collapse, leaving a region beyond comprehension. The early universe also challenges physics. During the first fraction of a second after the Big Bang, densities and temperatures were extreme. Conventional laws failed to describe conditions when energy, space, and time were compressed to unimaginable extremes, revealing the limits of our models. Exotic hypothetical objects, like wormholes, illustrate possible breakdowns. A wormhole connects distant regions of spacetime, requiring negative energy to stabilize. If such objects exist, they would bend physics to its edge, creating spaces where conventional rules no longer govern motion or causality. Dark energy, driving cosmic expansion, may also hint at unseen laws. As the universe stretches, unknown forces could interact with matter and energy in ways we cannot measure. At vast cosmic scales, physics may behave differently, breaking down the predictable patterns we rely on. Near the Planck scale, distances are so tiny that classical concepts of space and time vanish. Quantum fluctuations dominate, and even fundamental constants may fluctuate. This is the ultimate frontier where our current theories no longer hold any predictive power. In the core of collapsing stars, matter experiences pressures beyond comprehension. Atomic nuclei merge into denser states, and forces behave non-linearly. Our equations struggle to describe these conditions, marking yet another frontier where physics breaks down. Extreme magnetic fields around magnetars distort spacetime. Charged particles move along paths no longer predicted by classical equations. Light itself bends and polarizes under intense fields, demonstrating that even electromagnetic laws are tested at cosmic extremes. High-energy collisions in particle accelerators mimic, in a limited way, the conditions near singularities. Observing particles at extreme energies provides clues. Yet these experiments cannot fully recreate the universe's most extreme corners, where physics fundamentally fails. Cosmic censorship hypotheses suggest that these breakdowns are hidden from the outside universe. Singularities and extreme regions may be shielded by event horizons or cosmic boundaries. Even so, they remain real, silent places where all known rules of reality collapse. The places where the laws of physics break down are the universe's ultimate mysteries. They push the limits of human understanding, forcing us to confront the unknown. Black holes, singularities, quantum extremes, and cosmic edges remind us that reality is far stranger than imagination allows.